Have you ever stopped to think about what connects a diamond, the lead in your pencil, and, well, you? It all comes back to one single element, nature's master builder. Today, we're talking about carbon.
So here's our game plan. First, we're going to ask why carbon is the element of life. Then, we'll get into its big secret, sharing electrons. After that, we'll check out its incredible building superpowers, look at the molecular blueprints it creates, and finally, bring it all home and see how carbon shows up in your everyday life.
All right, let's kick things off and start unlocking the code of this amazing master builder.
I mean, this is really the big question, isn't it? What is it about carbon that makes it the foundation for everything, from the smallest microbe to the biggest whale? The best way to think about it is like this. Carbon is the universe's ultimate Lego brick. It can build just about anything. But how? The very first clue is all about how carbon gets along with other atoms. See, it doesn't like to fight or steal. Its real secret is that it's just really good at sharing. Okay, so picture this. Every atom wants a full outer shell of 8 electrons to be stable and happy. It's called the octet rule. Now, carbon has 4 electrons in its outer shell. To get to 8, it could try to steal 4 more, but that takes a ton of energy. Or it could give its 4 away, but that would leave it super unstable. So what's an atom to do? It comes up with the perfect solution. It doesn't take, it doesn't give, it shares.
And this brilliant act of sharing creates what chemists call a covalent bond. It's basically a handshake, a deal, where 2 atoms share their electrons so they both feel like they have a full set of 8. Honestly, this one simple idea is the bedrock of all organic chemistry. It's a total game changer.
And here's what's so cool. This sharing isn't just a one-size-fits-all thing. Nope. Carbon can share 1 pair of electrons for a nice, stable single bond, like you see in methane. But it can also share 2 pairs to make a stronger double bond, or even 3 pairs for a super strong triple bond. This incredible flexibility is exactly why carbon can build so many different things.
So, carbon's secret is sharing. But that alone doesn't explain everything. This one ability leads to 2 incredible, well, let's just call them superpowers, that really make carbon special.
Superpower number 1 is called tetravalency. Now that's a big word for a really simple idea. Because carbon has 4 electrons to share, it can make 4 strong bonds at the same time. Remember that Lego brick? This is like having a connector on the top, the bottom, and on both sides. It lets carbon build out in every direction.
And if you thought that was cool, wait till you hear about superpower number 2. It's called catenation, and it is just amazing. This is carbon's unique talent for bonding with itself over and over and over again. This is how we get the huge molecules of life, like the long, stable chains in plastics or the massive, complex rings and chains that make up our DNA. It's like an endless train of Legos just clicking together.
So, let's put those 2 together. You've got the ability to make 4 bonds, plus the ability to link to yourself endlessly. What do you get? You get an element that can create a practically infinite number of different compounds. That's why there's a whole branch of science dedicated just to carbon.
Okay, so we know why carbon is such a phenomenal builder. Now let's take a look at what it actually builds. We'll start with the most basic blueprints of all, hydrocarbons.
The simplest things carbon makes are called hydrocarbons, just hydrogen and carbon. That's it. And they come in 3 main families. You have alkanes, which only have single bonds between carbons. Then, if you add just 1 double bond, you get an alkene. And if you have a triple bond, it's an alkyne. Each one has totally different properties, all because of that bond type.
But, just carbon and hydrogen is only the beginning. The real magic, the real variety happens when we start swapping things out and adding other elements to the mix.
And that's where these things called functional groups come in. The best way to think of them is like special accessories you can clip onto a carbon chain. You clip on an OH group, and bam, you've got an alcohol. You clip on a COH group, and now you have an acid. These tiny little additions completely change the molecule's personality and what it can do.
All right, let's pull this all out of the lab and into the real world. How does all this chemistry actually show up in your day-to-day life? Well, you'd be surprised. You're using these compounds constantly. Let's just take ethanol. It's a simple little molecule, just a 2-carbon chain with that OH alcohol group clipped on. But look at all the stuff it does. It's in drinks, of course, but it's also a fantastic solvent in perfumes and cleaners, and we even use it as a biofuel.
All of that from one simple molecular blueprint.
Or how about cleaning? We've all seen that gross scum that soap can leave in the bathtub, right? Well, that happens because traditional soap molecules react with minerals in hard water. But detergents, they're designed with a slightly different functional group on the end that doesn't react that way, so they work great no matter what kind of water you have.
So how does soap actually clean things? It's all thanks to this clever little structure called a micelle. See, a soap molecule has two parts: a long carbon and hydrogen tail that absolutely hates water, we call that hydrophobic, and a head that loves water, hydrophilic. When you put them in water, they automatically team up to form this cool little sphere. And this is where the magic happens. These little micelles swarm a piece of dirt or grease. All their water-hating tails dive into the middle and grab onto the grease. At the same time, all their water-loving heads stay on the outside, facing the water. This traps the grease in a neat little bubble that can be easily lifted up and just washed right down the drain. It's so elegant, and it's all powered by carbon chemistry.
So, from its clever way of sharing electrons to its amazing superpowers of making four bonds and linking to itself, carbon really is nature's ultimate Lego brick. It has built literally all of life as we know it, and we've used it to create the modern world. Which really just leaves one big, exciting question. What will we build with it next?